Hi and welcome to this Leaving Cert Higher Level Applied Maths video. In this video, we're going to look at a previous exam question. So this question here is from the SEC Sample Higher Level paper and it is question 5, part B. So a rumor may be spread when a person who has heard the rumor interacts with a person who has not heard the rumor. Therefore, the rate of spread of a rumor within a group can be modeled as being proportional to the product of the number of people in the group who have heard the rumor and the number of people in the group who have not heard it. Okay, that's quite complicated. However, they have given us this differential equation and they have put it here. So if you can make sense of this, it is proportional. That's why we have the K to the product. So multiply the number of people in the group who have heard the rumor, so that's or, and the number of people in the group who have not heard it. So that's the total number, which is 1,200 students minus or. So we could be asked to make that in a scenario. However, here they've given that to us. So a student models the rate at which a certain rumor spreads. So anytime we're talking about rate, we're talking with respect to time unless they clarify otherwise. So that is D or, so the rate at which the number, so or remember is the number of people who know the rumor. So I have the number of people who know the rumor with respect to time, so D or dt. And that is equal to K or times 1200 minus or, where or of t is the number of students in the school who've heard the rumor at time t. One thing I would always kind of flag is the idea of what time is measured in, because depending on the question, it could be seconds, it could be minutes, it could be hours, it could be days, it could be years. So in this question, we're talking about days. On Monday morning, t equals 0, 100 students had heard the rumor. That's also going to be important because when t is 0, or equals 100, and that's going to be something we're going to need as we solve this differential equation. So the question asks us to solve the differential equation to find an expression that relates or, k, and t. So anytime we solve, we're always looking for this up the top. So we're going to get or equal, and there will be a k and a t in our answer. So they give us a little note here. So note that 1 over y times x minus y is equal to 1 over x times 1 over y plus 1 over x minus y. So if they've given us this, it must be in somewhat relevant. It must help us in some way. So let's start with our first step. So when we're solving a differential equation, our first step is to separate. We want to separate the variables to both sides. So on the left-hand side, I'm going to bring this whole piece over. I'm going to leave the k where it is. So it's going to be or times 1200 minus or with respect to or is equal to k dt, because that k is just going to get complicated if we bring it over as well. So then we want to integrate, and when the time is 0, or is 100, and when time is t, we want to find an expression for or. So there are limits. So now we're just straight into our integration. However, that thing on the left-hand side looks quite complicated. That's where we're going to start thinking about, okay, that note that they gave us, how can we use this to our advantage? Because if you take a look, that looks like a y and that looks like an x minus the y. So we can use that. So let's move over here to the side. So we have 1 over or times 1200 minus or, and that can be broken into 1 over x, where x is 1200, times 1 over y, where that is or, plus 1 over x minus y. Now what that effectively does is it's turned a product into a sum. And sums are much easier for us to integrate with, because if we have two terms, so two pieces added or subtracted, we can integrate each piece separately. So this has made our life so much easier. You can multiply in that 1200 if you like. You do not have to, and you can leave it out in front of the integral. So when we look here, we could end up with 1 over, I'm going to bring that 1200. The reason I can bring it out is it's a constant. It just has a number and it's multiplied by everything that's inside. So it's absolutely fine to bring it outside the integral to make life that little bit easier. minus ore. And that's all with respect to ore. That's the left-hand side. The right-hand side here is going to be relatively straightforward because it's just going to go KT, which we evaluate between 0 and T. So really our focus here is just on that left-hand side. So then when we want to start integrating that, we need to think about our checklist. So is there a formula on page 26? And the answer is yes. Both of those pieces are effectively a 1 over x. So if we think that's like a 1 over x, and that's like a 1 over effectively something like b minus x, but it is still both versions of 1 over x. So we're going to use 1 over x in the log tables to integrate that right-hand side. So I put everything back here so we can see it properly. So this 1 over 1200 is just going to sit where it is. The first piece becomes the natural log of ore. That's very straightforward. The next piece becomes plus the natural log of 1200 minus ore. But then you have to divide by the derivative of the inner function, which means we're dividing it by a minus 1. And that's going to be evaluated between 100 and ore. So effectively that's the same as minus minus ln 1200 minus ore. This becomes KT, which we evaluate between 0 and T. I'm going to leave this 1200 out here for a minute. We get ln ore minus ln 1200 minus ore. And again, we're evaluating that between 100 and ore. This is KT minus K times 0, so it's just KT. In order to make this a little bit easier, I'm going to actually multiply both sides by 1200 now and bring that 1200 over here. So I get 1200 KT. And as well as evaluating, I can tidy this left-hand side up using our laws of logs. So we're subtracting them. So that is ln ore divided by 1200 minus ore. So that's what we have. Let me just clean that up a bit. 1200 minus ore. And then we're evaluating that between ore and 100. So I'm subbing in, instead of ore this time, I'm subbing in 100. Okay. So we're, again, remember, we're trying to get we're trying to get ore on its own. We're trying to isolate that. Let's do a little bit of cleanup. So we have the natural log of ore, 1200 minus ore. And this becomes minus the natural log of 100 over 1100, which simplifies down to 1 over 11. Now, there's lots of different ways you can work with this. The natural log of 1 over 11 is kind of a nasty enough decimal, so you're welcome to put that decimal in. Don't round it too much. However, what I'm going to do is I'm going to use these laws of logs again. So I'm going to effectively divide this piece here, so the whole bit divided by 1 over 11. And when we divide by a fraction, instead you multiply by its reciprocal. So this becomes the natural log of 11 ore over 1200 minus ore, and that's equal to 1200 KT. Now, what I like about that is the fact we're not left with any big nasty decimals. Now I can take E and the power of each side, E and natural log undo each other, which leaves us with 11 ore over 1200 minus ore is equal to E to the power of 1200 KT. We want to get that ore on its own, so we're going to need to multiply out that fraction. So we get 1200 E to the power of 1200 KT minus ore E 1200 KT. I'm going to bring all the ores to one side, so 11 ore plus ore E to the power of 1200 KT is equal to 1200 E to the power of 1200 KT. Pull out that ore, gives me 11 plus E to the power of 1200 KT, and that equals 1200 E to the power of 1200 KT. So ore on its own, bring it across that bracket, we're going to divide by it, 1200 e to the power of 1200 kt divided by 11 plus e to the power of 1200 kt. And that's our answer for or in terms of k and t. So part 2 of this question says, by Wednesday morning, 250 students had heard the rumour. So remember, Monday is T0, so that means Wednesday is T equals 2, and we know that OR is equal to 250. Now, most students will go and take their final answer and plug that in. If you do, you have a good bit of work to do because the fact that we're looking for K and K appears in 2 different parts. So you want to work that through and sub that in, that's absolutely fine. However, if you want to save some time, and this exam can be very time consuming, it is nice to go back to the previous part and look for a time when K was kind of not isolated because we won't have had it on its own, but it's only in a single term. So actually, if I go back to our previous part, we had a line that was ln 11 OR over 1200 minus OR is equal to 1200 kt. And that's a much better line for me to work with because my substitution is going to be so much quicker. So when I plug this in, so 1200 minus 250, and that equals 1200 times 2 times k. So then to get my final answer, I'm going to do k is equal to the natural log of this simplifies down to 55 over 19. And then I'm going to divide that by 1200 by 2, which is 2400. And that gives me my answer for k. When you put this into the calculator, we get quite a small number. So we get 4.4287 by 10 to the power of minus 4, which is 0.0004427. Now, if you feel like that is too complicated to go back and find a different line, absolutely try it by subbing in the value of OR and T into what we have, but it is a much longer calculation in that case, but you should get exactly the same answer. So if you have worked it the long way, or if you want to work it the long way, here are the steps needed to go from our final answer from part 1 to a value of k without backtracking to a previous step in part 1. So part 3 asks us to sketch the shape of a graph of OR against T to show how the model predicts the spread of the rumour. So what we need to understand are values of OR for each of those values of T. So you have a few different ways to do this. You can absolutely just go with your formula for OR into your calculator and sub in values of T and change them. Another option is to use the table or function in your calculator. You can put it in terms of f of x and x, and it will give you everything you need. Here is the table that we get. I've put in 2, even though it's not marked as one of the days because we were given that information in the question. So we have at t equals 0, we have OR equals 100. We were given that. T equals 2, OR equals 250. We were also given that. And then we've calculated when T is 5, T is 10, 15, 20, 25, and 30. So if we plot these points, they're not going to be absolutely perfect, but we can see that from kind of T equals 15 onwards, we're pretty much up there at the 1200. So we get a graph that is roughly this shape.